Hey, I want to walk you through number 8 on your review packet because I want to show you everything to do on the calculator. So I'm given two functions. I'm going to put the first one v of t and y1, the second one a of t and y2. Make sure as soon as you see a trig function, you make sure your calculator is in radian mode. First thing we're going to talk about is the speed of the article increasing or decreasing at time t equals 5.5. Well, y1 is the velocity function and y2 is the acceleration function. So here's what we need to do. Remember, for a particle to be speeding up, velocity and acceleration have to have the same time. So I'm going to store 5.5 in x, and I'm going to evaluate y1 and y2 and see what their signs are. So I go alpha trace y1. I see that the velocity is negative. Alpha trace y2. I see that the acceleration is negative. Since they have the same sign, the particle is speeding up. Part B, find the average velocity for the time period 0 to 6. So I'm going to do the average value function of the velocity function. So I want to put in a fraction first, 1 over 6 minus 0, which is simply 1/6. Oops. Times the integral, math 9, from 0 to 6 of the velocity function, which is in y1 and dx. Oops. So the average velocity from 0 to 6 is 1.949 meters per second. Total distance traveled, well, we know that that's the absolute value of velocity, so the absolute value of the integral of velocity. So we're going to go math 9 again, from 0 to 6. This time I'm going to put in the absolute value signs and alpha trace. Uh-oh, what did I push? Well, hopefully it worked for you. Mine's freezing now. Okay. So I have 0 to 6, absolute value, alpha, trace, enter, dx. Ay, ay, ay. And the total distance traveled should be 12.573. Great. Now it says, for 0 to 6, the particle changes direction exactly once. Find the position at that time. So I need to know when it changes directions because I only want to integrate from 0 to whenever it changes direction. Well, I know it changes direction when velocity equals 0. So I'm going to go to my graph. And I'm going to tell it not to graph the acceleration because I don't want to see that. But it's not going to let me. Well, the acceleration is the red one. And remember, your window is only 0 to 6, so this is about 6 right here. So the only place velocity changes direction is right here. If I tried to do second calc 0 right now, it probably wouldn't work because I don't have any negative values in my window. So I need to change my window. I'm going to go 0 to 6, and I'm going to go -2 to 10. And now I'm going to tell it not to graph the acceleration because I don't want to wait for it. So I make my equal sign not black, and I hit graph, and it's only going to show me the blue. Wow, it's slow. So I want to find that 0, second calc 0, left bound, enter, right bound, enter, enter. 5.1955. So I want to integrate from 0 to this point. So I'm going to go back to my main screen, and I'm going to go math 9. And I want to go from 0 to, what did I say, 5.1995, I think, of y1 dx. Oh, I thought it automatically went over there. Enter. Now that's the displacement, but you have to remember the particle started at 2. It says x of 0 equals 2. So the position at that time is 14.134. So that was a pretty solid free response question that every single piece of work could be done on the calculator.